Hello everyone, I have here a end-to-end MLOps pipeline predicting the supply chain late deliveries. This is a common pain point of a lot of companies whereby they missed thousands per order due to late deliveries. And in this solution, the ML pipeline that I've developed is using the XGBoost with Meta Learner. So these combinations give a F1 weighted of 0.69, which is by far the best I've done, and I have tried to not have any data leakage. The pipeline is an end-to-end solution whereby we have from data ingestions, filling and cleaning data at the silver layer, as well as doing the feature engineering, and until the go level, the pipeline architecture built based on ZenML. Okay, so this end-to-end process is done in ZenML, orchestrated from all the way from data ingestions right up to deploying of the model. And after go live, I also have drift monitoring being in place, as well as MLflow, and it is all automated. Right, the rest are set up. So let me just show you my analysis done in EDA. So within the EDA, the main focus is not to have any data leak. So I have data audit done for leakage, as well as the trying of which is the features that is best to be used. Now let's look at the dashboard of the end result. Here I have two dashboards. First is the late delivery predictor. And in here, I have this input form. So what will cause it to fluctuate? Let me just do some quick testing. Yeah, the shipping mode is a very influential feature here, and you can say that once the input changes, the model is intelligent enough to predict based on the input whether it's going to be a high risk late delivery or not. Right. So this is a predictor that the business can use, and it's real time. Okay. Now going to the executive dashboard, we'll first show the KPI, which is based on three matrices that I use. So they are F1 weighted, recall for late orders, as well as the AUC ROC. So these are the combination. And because I have been very careful not to have data leakage, like I removed the shipping date rail and bring in calculated fields like the shipping distance, which is a derived feature. So this is the best result that I get. And okay, if we go down, in this executive summaries, there's a lot of options. There will be business, cost analysis, and this actually shows the total numbers of orders by percentage that is false negative and false positive. All right, as well as the SHAP analysis, which is generated after the pipeline is completed. And down here, you can see that schedule buffer, shipping mode, schedule shipping date, as well as the last one is the shipping distance. These are the very prominent features that business has to look out to. There you have the matrices by model versus baseline. Baseline will be the dummy classifier that does nothing. You can see that my model is always outperforming the dummy classifier. Whereas for recall, this is because every time it's always detecting late. That's why it's a 1 for dummy. But mine is more realistic. It is 0.605. These are the advices that is to be made by the business. As well as I have the confusion matrix here. And you can see that both the true negative and true positive are much higher than the false negative and false positive. Lastly, in this model, I have done a 37-month forward backtesting window. So it is to show that how reliable my matrices are. You can see there is a table that you can view the detail by month, as well as the breakdowns of on-time orders and late orders. You can see that the performance is quite steady. It is not fluctuating. Lastly, when you go live, I have this data drift monitoring that you can use. So this is the log table that we have after each run. Yeah, and the status is a simulations of the KS tests as well as the chi-squared skill of the data. That's all I have. Thank you.